Hi, my name is Aditya. I am the CEO of Automatsky, and today I am going to be talking about weather forecasting. When I used to travel to the US and Europe, etc., I used to see that weather forecasting there is so accurate that if the forecast says that it is going to rain from 6 p.m. to 6:05 p.m., people used to wait in their office and leave either before 6 p.m. or after 6:05 p.m. to catch the metro or go out. It was quite accurate. The situation is not the same in India. Now, let us go through what infrastructure and investments India has made into weather forecasting. Weather forecasting in India is primarily conducted by Indian Meteorological Department, and it uses weather prediction, physics-based models, satellite data, AI-based tools, particularly under the mission MOSM. It has a network of 1,000 automatic weather stations, satellites, INSAT 3D, and Doppler radars to predict monsoon, cyclones, and short-term weather. So it does a short-term forecast of 1 to 3 days. It does a medium range forecast of uh, 3 to 10 days. It does a nowcast of up to 3 hours, and it does a long range forecast of monsoon, etc., and revises it 2 3 times. Now they are trying to adopt AI and machine learning and multi-model ensembles using multiple climate models to improve accuracy for long range seasonal monsoon forecasts. What is the computational power that IMD has? Now, IMD has some of the country's most powerful supercomputers. They have Arca, which is 11.77 petaflops, Arunica, which is 8.24 petaflops. Together, they have a total capacity of around 22 petaflops. And Arca is located at IIT M Pune, and Arunica is located in Noida. Now, at Automatsky, we have built a platform that does climate simulation, and I'm going to be showing you a demo of that. Now, look at this folder. I'm in D drive temp vibrant Gaia folder, and it is empty. And here I have a command prompt which will initiate the climate simulation on a HPC cluster. Now, everybody says that Automatsky uses large HPC clusters to do quantum simulations. But that is not true. We don't have HPC clusters because we don't have millions of dollars to invest into supercomputing infrastructure. And these supercomputing machines cost tens or if not hundreds of millions of dollars. And in quantum simulation, you cannot do a state vector simulation of more than 40, 45, or 50 qubits. But which brings me back to the point that we don't have HPC clusters. So to show this demo, I have gotten access to a research HPC cluster, which is more than 6, 7 years old. So it is not the best that we have, but let's see what we do. So I'm going to run a 72-hour forecast over a VPN tunnel to the HPC cluster, and I'm going to calculate variables like temperature, wind, rain, humidity, pressure, geopotential, etc. It's a 72-hour forecast, and it will keep all the visualizations in the forecast visuals directory. As you can see, the temp directory is empty right now. I'm going to kick this off. It has initiated the job and it is running. Now, if you remember, IMD forecast takes hours on huge supercomputers. Now, this will take a couple of minutes and it takes more time to export the visuals and the data than to actually do the simulation. Once we deploy large HPC clusters, not supercomputers, but HPC clusters, this timing is going to come down even more drastically. So we are doing a 25 kilometer by 25 kilometer resolution simulation of 72-hour horizon. We have actually connected to a data source to get the latest satellite data. So this is live climate simulation. And as we talk, now you can see the clock on my laptop and you can see the timer progress bar here. It will take approximately 20 minutes. more time to export data than to actually simulate. So I'm going to pause the video now and I'm going to resume it a bit later. And we are back. Now, as you can see, the simulation has completed. It took 10.5 minutes, and then a couple of minutes to show the forecast summary and extract all the visualizations and data dumps. Now, it has dumped the numerical data to India underscore 22H 72H.NC, which can be processed automatically. You can see the wall clock time. It is 7:52, and I have not touched this laptop since then. The displays are in the same place. And if you see this folder here, now I'll close this and now we can look at the visuals. If you see this folder, here is a timestamp of creation. It was created a minute ago. These are all the visuals in a dashboard. I'm going to put it in detail mode. So you can confirm the timestamps. It was writing it for the last 3-4 minutes. And let us, so you can look at the temperature visual. This is a temperature forecast and it doesn't change very drastically. And I'll let it run. There is a slight change and it is not visually discernible, but numerically you can make out the difference. I'll close this. Uh, this is the wind speed, X and Y direction wind speeds. Now there is a there is a interval in which we capture the data from the simulations. Our platform's name is Vibrant Gaia. Gaia means GAIA means Mother Earth, and it has 5 or 6 built-in models which are physics-based, multi-physics-based, and AI-based, and hybrid models. Now it is a bleeding edge platform for weather forecasting. It is ready today. This is the first baseline version, which I'm showing to you live. It can do all time horizon forecasts of various time horizons. It can do a monsoon forecast also, and it can be used for forecasting weathers at other countries or globally also. So it has this forecast has happened on a scale of 25 kilometer by 25 kilometer grid size. We can decrease it to 1 kilometer by 1 kilometer grid size. And uh, if this is the pressure, chart, and which doesn't show much. Now, if we set up a production grade HPC cluster, then we'll be able to uh, decrease the time even further, and we can do real-time forecasts for the entire globe. And from here we need to continue to work on future versions of the platform, developing the AI models, increasing the precision and the physics behind those models, and we'll go from there. Thank you very much. This is all we had for you today. It is a pleasure, and let us know how we can help you. Thank you.